Good morning, everyone. Thank you for joining us this afternoon for the Range Cattle Research and Education Center's monthly webinar. My name is John Arthington, and I'm a professor of animal sciences and the center director here at ONA. And when I was thinking about a topic to share with you today, this one came up because it's something that we do a lot of in our program here at ONA, and that's assessing overall trace mineral status of grazing beef cow-calf herds. The students in my program have been involved in this part or this aspect of our outreach for many years, and I thought it would be kind of a good topic to cover with you and explain how we do that, the steps that are involved, and maybe some of the outcomes that we would expect. I have a short 5-minute video that Andrea is going to come up and help us with right at the end to give you a little bit more information on the process. So why would we want to do these herd trace mineral analyses? Generally, it's technical sales and service individuals that are involved with the sale of mineral products or technical support of mineral products, and they might have a need to evaluate the overall trace mineral status of the cow herd. When they do this, there's generally two common situations. Either the owner or manager of that cow herd perceives that there is a problem, there may or may not be, or that simple trace mineral assessment is just done as a service from the company supporting that cow herd or that owner of the cow herd to the owner or manager. So generally, I ask people to think about this in an order of assessment. A lot of times people come in and the first thing they want to do is just analyze or test the trace mineral product to see if it meets the specifications that are being listed. Other times people just want to collect tissue or blood samples from their cows and just look at the overall trace mineral status of the cow herd. And this can be expensive and time consuming and might not really result in any logical solution to the owner or manager. So I'm going to go down through this assessment with you point by point and talk about them then individually. First of all, just getting a better understanding of the ranch management system and understand how the cows are fed and how they're supplemented would add a lot to the overall approach. And then feedstuff analysis, like the forages or the supplements that the animals are consuming. In some cases, not so much in Florida, but in some cases, a water analysis will be beneficial. And then some measure of mineral intake, and this is probably the most important of all. A lot of times people will formulate minerals, and I'll get into this later, and the minerals probably and are formulated properly, but the calves and cows just don't eat them at the amounts that are required to deliver the supplemental nutrition that the cows need. So mineral intake management is important. And then the one we talked about here, formulation, and then analyzing those supplements. After we've covered all of these, we might want to look at overall cow herd mineral status, and I'm going to talk about that as we go. And then the last one is the communication and follow-up, and I think this is one that is probably the most commonly overlooked, and certainly I would agree in our program, is just going back after all of this is done and finding out what changes were made and did it result in any differences in the overall performance or concerns that the owner had with that cow herd. Now, I've weighted this just from our experience as what I think is the most important through all of it. And you noticed on here, I have mineral intake management as about 1/3 of the overall issue. This is by far the largest issue that impacts trace mineral status of the cow herd. It's just getting them to eat it. And then feedstuff analysis and ranch information coming in next. You can see that this makes up 2/3 of the total before we even analyze any of the status or mineral status of the cow herd. But yet the latter is what a lot of times people focus on to identify potential problems. So just the ranch and farm information is an information gathering process. I think it's important that we know what are the goals and expectations. Why does the producer think that they have a problem? And if they make a change, what will be measured to identify that there is success? And then I always like this one, is what factors could be ruled out that might have a more direct impact on the decline in production that the owner or manager sees. And so oftentimes energy and protein should be addressed first, right? If you see a cow herd that is in suboptimal body condition score, maybe the cows are averaging 3.5 or 4, they may very likely be mineral deficient, but they're also energy and protein deficient. And when you correct the energy and protein deficiency, you probably will correct the mineral deficiency just as a simple pull through. So energy and protein are generally more important than mineral nutrition. And then are production losses well defined? This next one is, what are the sources of supplemental trace minerals? When I first came to Florida, there were formulations that contained, for example, copper oxide. Copper oxide is commonly used in poultry and swine formulations, but copper oxide is entirely unavailable source of copper for beef cattle or dairy cattle. Should never be used in formulations. Today, you see that much less. It's not quite as common. And then I also want to know, have there been any recent changes in management, particularly nutritional management of the cow herd? And maybe some solutions can be found there. So the overall trace mineral status of that cow grazing in the pasture, it's not just the supplemental mineral that they're receiving. In fact, that's second to the trace mineral status of the forages that those animals are consuming. So it's a summation of 3: the forage intake, the supplement intake, and for us in Florida, much far in third place is water intake. So another thing I'd like for you to know is that if you go out and collect a forage sample, clip a forage sample, I'll talk about this a little bit in the next couple of slides, and you analyze that, and let's say the sample comes back at 0.15% phosphorus on a dry matter basis, and the cows are lactating. You might say, oh no, you know, the forages that they're consuming are deficient in phosphorus. That might be true in what you collected, but cattle have an amazing ability to select, and they will select a higher quality forage than what you're able to grab in a hand sample. And research has shown that they will consume about 1/3 greater quality forage than what you can hand select. And so a lot of times people think about our cow herd as being deficient in phosphorus when most of the time they're not. Given an opportunity to select, cattle will consume a much higher quality forage than what we can clip. Now, if you look out over the pasture and there's no grass there, it's right down to the ground, then they don't have an ability to select, do they? And so then the deficiencies could be more important. We also need to worry about trace mineral antagonists. I'm going to list 3 of them here, but sulfur is by far the largest contributor. I generally tell people that if your forage measures 0.2 to 0.25% sulfur on a dry matter basis, you will have a problem with an antagonism. Sulfur antagonizes both copper and selenium, and these are our 2 most limiting trace minerals for grazing cattle in Florida. Sources of sulfur include fertilizer from ammonium sulfate used as a nitrogen source, different supplements that can be high in sulfur like distillers grains, brewers grains, liquid molasses can all be high in sulfur. And then water can too. But I always try to just let people know. A lot of times people think that they have high sulfur in their water. Why do they think that? Because they can smell it, right? They smell that rotten egg smell. That rotten egg smell is actually hydrogen sulfide that is aerosolized. It's volatilized off of the surface of the water, and your nose can smell it in parts per trillion concentrations. Generally, water that smells like sulfur is not high in sulfur. Okay, the overall sulfur content may be quite low. Our research center is an example of that. We do have some hydrogen sulfide in our water, but overall sulfur is quite low. High sulfate water, like they have in the Dakotas and Nebraska, many places there, that's very problematic, can contribute to the overall sulfur content of the diet, but you can't smell it. So just because you can smell it doesn't mean it's high, and just because you can't smell it doesn't mean it's low. Molybdenum is another antagonist that can be high in our forages, particularly forages that have been treated with certain sources of biosolids or forages that are grown in high organic, high pH soils. They'll generally accumulate molybdenum, and molybdenum can have many impacts. If molybdenum combines with sulfur, it forms a complex called a thiomolybdate, and thiomolybdates have a high affinity to bind copper. So you might have, some of you know that we feed in our copper studies here, we feed sodium molybdate and sulfur to try to potentiate copper deficiency. But what's interesting, and things that we've learned probably in the mid-2000s, is that molybdenum without sulfur can have a direct impact on estrogen metabolism. And it's probably that direct impact that has linked copper to reproduction for many years. When we thought that copper had an important role on reproduction, we now know it doesn't, but rather molybdenum has a direct effect on estrogen metabolism. But we notice the copper deficiency because the molybdenum pulls copper out of the body. Does that make sense? Maybe a little bit. So iron can also be a problem. We don't really have a lot of high iron problems in Florida so much, but it can antagonize copper as well. So when a mineral supplement is formulated, this is why I want to focus a lot on producers in terms of mineral intake management. The tag is required by the American Association of Feed Control officials to have the targeted intake. So if you look at our mineral, if you pull off a tag and read it, it says formulated for an intake target of 1.75 ounces per day. A lot of times you'll see tags that say 2 to 4 ounces. Very common in Florida. If you go further north in the high plains areas, the tags will say 4 to 6 ounces per day. All right, so that is the formulated amount that on average the cow is supposed to consume to achieve the mineral supplementation target that that product was formulated for. Now that's a problem if they don't eat it. And we know that that's a problem, and it's an extreme problem in Florida where intake is often driven by a salt craving, by a craving for salt. And we know what drives that is that as temperature and humidity go up, or as forage dry matter goes down, or if cows are lactating, they crave salt more, and they will eat more mineral. Now, just the opposite, if these animals are consuming dry forage or hay like we have right now, and they get supplement that has a little bit of sodium in it, then they don't crave salt so much, and we see mineral intake go down. It's important to note that salt craving is not always linked to sodium deficiency. And a lot of people suggest that it is. Certainly, if cows are sodium deficient, they will crave salt. There's no doubt about it. But when cows are receiving adequate sodium, they will still crave salt. And they will consume salt far above their physiological requirement. In fact, salt is the only mineral that if given an opportunity to eat, cows will always meet their requirement by consuming salt. They'll always meet their sodium and also follow through their chloride requirement by consuming that salt. It's the only one. And so we call that nutritional wisdom. They have a nutritional wisdom to consume salt. If you put copper sulfate out, cattle would have extreme copper deficiency before they would ever eat it, or any form of copper. The same is true for other elements. This is a slide that I show a lot, and it's a 3-year summary just to help give you an example of how cattle change their consumption of mineral. What we call the old Brayford pastures over here, for 3 years, we analyzed or just measured the amount of mineral that each of those 8 cow herds ate every week for 3 years. And this is the percent refusal. What this means is we were targeting a 3 ounce a day mineral. So we took the 20 cows times 7 days times 3 ounces, and that's how much we gave them. And then we just came back at the end of the week and we measured how much was left. If they ate everything, that was 0% refusal. And you can see in the summer months when they're craving salt, they eat everything. But look how much they refuse to consume because they don't crave salt in the wintertime. This is particularly problematic in Florida because the wintertime is our really important time for the cow herd, isn't it? They calve in November. We're trying to rebreed them in January, February, and March, and they're lactating calves during that time. These are really important physiological periods for optimal mineral intake. But unfortunately, cows don't crave minerals so much. I like to show this. These are some data from Kansas, South Dakota and Kansas, in the High Plains area, where they're feeding minerals that are targeted for a 4 to 6 ounce a day or 4 to 5 ounce a day mineral intake. And even though there is variation over the year, it's not nearly as dramatic as what you see here, right? So other places of the country deal with variation, but I don't think it's nearly as dramatic as what we have in Florida. So let me go on now to mineral formulation and analysis. And too often, I think that we look at this step first, when really some of these other areas are probably as important or more important. It's often driven by this impression that people might get from consultation from their friends or neighbors or other salesmen, or just advertisements that they might read in popular press or magazines. I often will get this call that says, you know, John, I'm feeding this mineral. It's $600 a ton. It has 2,000 part per million copper, but yet another mineral that is the same price has 3,000. Shouldn't I buy this next one? And the answer is always no. The difference between that 2,000 and 3,000 is minimal. But all of these other issues like antagonists and intake, formulation, all of these have much greater impact than that 1,000 part per million increase in copper. So what I ask people to do is try to get familiar with the product that they're currently using. And if not familiar, look at some of these key things. So I often look at, for example, the ingredient sources, the zinc to copper ratio. I want to see a ratio that's at least 2 to 1 and maybe even 3 to 1, but 2 to 1 is a minimum. I always look at that targeted intake, okay? The targeted intake, let's say it's 3 ounces a day, and I multiply that by the selenium concentration, and I want that to be as close but not over 3 milligrams of selenium a day. The reason for that is selenium is the most limiting mineral for all forage crops in Florida. It's the most limiting trace mineral. But there's a federal law that caps the amount of selenium that we can give to beef cattle, grazing beef cattle. It's capped at 3 milligrams per day. If you look at our mineral there, that's why we target a really low intake mineral with a high selenium content, so that we can optimize our opportunity of achieving the 3 milligrams a day selenium intake. And then I always tell people when testing, if you want to test your mineral or your supplement, take 3 random samples throughout the bag. Don't take it right at the top of the bag because you have settling of the elements in. But as you pour the bag, take it through that mid part of the pour and 3 random samples for analysis. Now, here's a problem that people run into a lot. If you walk out into the pasture and you want to do a trace mineral workup where you collect forage samples and mineral samples, or you're just talking about your mineral, it's very common for producers to go over to the mineral box and take their hand through the mineral and just look at it, right? Take the mineral up and look at it in your hand. Now, you've got your hands covered in mineral dust. And if you go over and collect forage samples, you will contaminate that forage. And we see this time and time again. It's just human nature. So be very cautious about contamination between a very highly concentrated supplement that you have out in the product, out in the field, and the lesser concentrated forage. The mineral in the person's hand here, that could be 3,500 part per million copper, where the forage might be 8 part per million. 3,500 and 8. So imagine it just takes a little bit of dust on that grass to spike that sample and cause an erroneous laboratory result. So if we go through all of these steps, generally a reasonable plan can be devised. However, assessment of cow mineral status may tell us more about the overall trace mineral situation for that herd. But it's important that we analyze the proper tissue. Of all the tissues that we can look at, muscle and liver are the 2 that are probably the most reliable for trace mineral status. Really, although many minerals are stored in the liver, it is the primary storage organ for selenium and copper, definitely for copper, and also very good for selenium. Other elements that are important like cobalt and zinc and manganese, these are all divalent cations that are important for cow herd nutrition. You can also measure them in the liver. But there's a big flux, like for example, zinc fluxes back and forth between long-term storage depots like bone and lesser term soft tissues like muscle. And zinc might just be a kind of a short-term indicator. Manganese, for example, also, you can measure it in the liver, but it's often just reflective of what that cow ate 3 or 4 days ago. But selenium and copper, it's very good in the liver. And that's fortunate for us because those are the two elements that are commonly found to be deficient in grazing cattle. You'll often hear me, if I talk to producers about it, I call it the elements sentinels. They're sentinels of overall trace mineral status. Generally, if your copper and selenium status is good in your cow herd, zinc, manganese, cobalt will also be good as well. Blood is an unreliable indicator with the possible exception of blood selenium concentrations. Whole blood can be used generally as a good indicator of long-term selenium status because the red blood cell will incorporate selenium. So it can be a good indicator. But remember, the half-life of the red blood cell, I believe, is about 60, 80 days. I'm not entirely sure, but it's about that. That means that you could have really good selenium status in the cow herd, but they could be in a deficient status. You just haven't picked it up yet because there hasn't been adequate turnover of red blood cells. And so there's problems with that. You should always select cows for sampling that represent the average of the cow herd. And these should never be the cows that the producer says, well, we ought to sample her, she didn't get pregnant, or this cow's been a poor doer, we should sample her. Those are the outliers. We're interested in the average of the herd, and those are the cattle that we should sample. Non-pregnant cows are the best candidates. So I'd like to sample, the best time to come in and sample a cow herd is right at the time that you're turning out bulls. Hopefully the cow herd's mostly calved out. The cows, if they're going to be deficient, that's the time of the year that you have the highest likelihood to pick it up. And the cows are generally shouldn't be pregnant at that time. So the early postpartum period. This is a common figure, and I cite this a lot in publications where we're trying to show that blood is an unreliable indicator. And this is regressing blood copper concentrations that you see on the x-axis with liver concentrations that you see on the y-axis, I think. I can't see it from here. But you could do it either way. It's just correlating the two together. And what you find is it's not until the cattle become deficient in copper in terms of liver tissue concentrations that blood starts to become a reliable indicator. And you see that as the cows become lower and lower and lower in liver copper concentrations, you start to see the blood values correlate very well. They're all starting to fall on the line. But when you get out into greater concentrations or copper status, greater concentration in the liver, the blood values are all over the place. So a lot of my colleagues say, John, I disagree. Blood is a good indicator. It is a good indicator if the animals are very deficient, and that's probably true. So we generally pick 10 to 15 cows from the herd, and we can use a small sample size now, and I'll show you that in a minute. And then we should attempt to collect the sample from the same area of the liver, and I'll also show you that. And results should be reported only on a dry matter basis. And I'm going to explain that too. So here's a picture of Juliana Hanches collecting a liver sample from an animal. And we use this commercially available 16-gauge Tru Cut biopsy needle. Now, years ago, the research center here, when Dr. Chapman was really starting his program, he would use this much larger instrument that is about the diameter of my finger. And that would take a big core sample. Although it was rare, there were instances of death loss just from internal bleeding at that time. You had to have that large tissue sample because the analytical equipment that's used to analyze the tissue was not that sensitive. But today, we can use a very small sample size and get a very reliable calculation or analyses of the trace mineral content. So, you know, the liver's a big organ. And when we teach people how to collect these samples, if you've ever seen a posted cow or a cow that has went through a necropsy and you saw the liver, you wonder, how on earth could you ever miss that thing? It's huge. But across the face of the liver, there will be some differences depending on the lobe of the liver that's sampled of mineral status. That's just the fact. So we want to try to collect the sample from a common location on the liver. And I'll show you that a little bit more as we go on. So Andrea, will you help me start the video segment? Last week, Andrea filmed me collecting some samples so that we could show it to you here today. So it's about 4 or 5 minutes, and then I have about 4 or 5 more slides to show you.
So we'll clean the site just one more time, and now we're ready to glove up and come in and make our incision. Another important reason for wearing latex gloves when you collect the sample is that to collect a sufficient sample, you're going to need at least 3 full core samples from our biopsy needle. Now, while we collect these samples, I prefer to store them on the back of my glove. While you're doing this, it's very important that each of those samples stay clean and free from dirt or debris. Anytime we add anything extra to the sample, in whatever form it might be, dirt, debris, or dust, or something off of our glove, that's going to add to the analysis of that trace mineral we're looking at. Like I mentioned before, we will not be making any cut with the scalpel, but instead we'll be making a punch right at the area where we wish to collect our sample. Using this sterile towelette, I like to dry off the biopsy needle first with it in its extended position. Now with it closed, we're ready to start to collect the biopsy sample. On these taller animals, like this cow, I prefer to start the direction imagining that I'm aiming the needle for her front left elbow. So we start the needle in and we just get past probably a ½ an inch. At that point, we make our punch, do the 180-degree turn, and then the cut. Once we remove our biopsy needle, first let's take our sterile swab and remove any blood that might be there. Then push back out the punch and look at the biopsy collection. This collection here is a good sample. You can see that there is some fat included on the end of the sample. Once we remove this from our biopsy needle, it will be important that we remove that from the total liver sample, and that will be easy to do. Simply take the needle and wipe it onto the back of your glove, and the sample comes off. Oftentimes, anything that isn't connected to the liver, like the fat in this sample, will remain on the needle. Now, we will clean the needle, any excess tissue or blood, so that we don't reintroduce any of that back into the incision site. As you can see, the first liver biopsy sample adheres well to the glove. And although you need to be careful that you don't contaminate it with any dirt or hair, you often don't need to worry about it sliding or falling off. It'll stick quite well. The animal has moved back again a little bit close to this bar, but we're going to go ahead and sample again. Often, after you've collected your first sample and you found out maybe how easy it was or how difficult it was, you might find that you can go in almost any direction in your incision site and collect a sample. Now we have 2 good biopsy samples. For a sufficient sample for trace mineral analysis, we'll need to collect 1 more. Move just past the rib. It's important that as you're collecting the sample, everything is in a forward motion. So once you move the biopsy needle in, you never move it back until you've collected your sample. So we make a punch, 180-degree turn, then forward with the cut. Then just wipe it on the back of your glove as you did the others. As you look at your samples, before you put them in your tube, make sure that you remove any pieces of hair that might be attached, as is the case here. After we've collected the biopsy sample, we need to put it into a tube which we can transport it to the laboratory for the trace mineral analysis. When doing this, I like to use a large gauge needle that's very fine that we can use to ball the sample up. We can do this right on the back of our glove and then insert the tube. Check to make sure that there isn't any hair or debris in the tube or around the top, and then cap it. The very next thing that you should do is label the tube with the cow ID so that you realize when you get the samples back which cow they related to.
Okay, thanks, Andrea, for putting that together. So you see the sample's pretty easy to collect, right? And it's ends up being a reliable indicator of trace mineral status, but there are other things to be concerned about. And one is, and that I pull my hair out when I see these results reported on a wet weight basis, or sometimes called as received basis. You saw that on the back of my hand, those samples were on the top of that latex glove, and they were very really exposed to air. And so the dehydration process starts right away. And so even though that cow in that video was a pretty easy animal to collect, what if she backed up or something and they had to be repositioned? It just took another 3 or 4 minutes. That whole time, that sample is dehydrating on the back of your hand. And if it's reported on a wet weight basis, that means that as the moisture is dehydrating away, the minerals as a percent of the total tissue remaining goes up, right? Does that make sense? And so there's a simple way around this, just like feedstuff analysis. Dry the samples. Dry the samples first. But unfortunately, some labs aren't doing that. I'll even see results that come back from laboratories that report on a wet weight basis, and in the description of the results, it'll say sample appeared to be desiccated, means slightly dried. Well, results could be erroneous, right? Because slightly dried. There's a simple solution: dry the sample before you analyze it, and that would solve the problem. So labs that report it on a wet weight basis, if there was no drying at all, the average moisture content is 72% in liver, right? So you can convert them back and forth, but there's no way to control that dehydration. And so results reported on a dry matter basis are much more reliable. I try to show this here, that if you had 2 laboratories, one reporting on a dry matter basis, and the copper was 75% liver copper, that would convert to, 75 part per million liver copper on a dry weight basis. If there was no dehydration, that would be the same as 21 part per million on an as received basis. But you take that same sample and just look at small amounts of dehydration and look at how it is elevating the liver copper concentration artificially. Okay, so this can be a problem, but it's easy to work with. So the last thing I wanted to point out is that follow-up is essential. All right, going back to that farmer or rancher and looking at what they might have implemented as a change, if any. Maybe everything was fine, or maybe it had nothing to do with the mineral. But did they implement anything, and did they record or notice any changes towards the intended outcome? So records of herd assessment, such as forage mineral results, this intake evaluation, very important, cow mineral status. If all of those are kept and cataloged well, they can serve as a long-term indicator of the trace mineral status of both that ranch or farming operations and the cow herds that are grazing it. So with that, I'll thank you for your time and address any questions that you might have. Before we do that, and before I forget, I just want to let everyone know that next month's ONA webinar will be on March the 12th, presented by Britt Smith, a postdoctoral associate that's part of the long-term agroecosystem research, and he will give the project highlight that day, entitled Effects of Prescribed Fire on Cattle Use and Foraging Behavior in Subtropical Grazing Lands. So if you're available, please try to join us on that day. Are there any questions that I could try to address? Anything? If there's anybody that has a question that is on logged on with the webinar, distant, I think you can type that in, and I'll try to address it here. Okay. Any questions? Dr. Vendermeer? Yeah. Yeah, good question. So the question was on that 3-year graph, the first year had a lesser refusal than the other 2 years. I don't really know. We tried to relate that to winter rainfall. Like, this is a fairly wet winter. We would expect greater amounts of intake or less refusal. But that was not the case when we looked at that. But that's what I would have related it to. The cows were supplemented exactly the same. They just didn't have as great a refusal that year. Another thing that's interesting with refusal as well is if you feed haylage. You know, here at the center, sometimes we'll feed round bale silage or haylage. Cattle will consume more salt, then subsequently more mineral when they're fed haylage than when they're fed dry hay, just because of the intake of water. Dr. Salim? Okay, the question is, what can you do to promote intake? So intake is generally driven by salt. And salt is an interesting ingredient because it can do two things. Salt can stimulate intake in animals that crave salt, so you can get animals to eat because of salt. It can also limit intake by adding significant amounts of salt to the diet. So at the research center here, we have what we call a summer blend and a winter blend of mineral. The formulation of trace minerals in our product are virtually the same, but the winter supplement has 20 to 30% salt, and the summer supplement has 50 to 60% salt. And so we know that cows are going to consume more mineral in the summer, so we add a lot more salt to it, so that they crave their salt craving, or I'm sorry, satisfy their salt craving and don't eat as much. Now, so to answer your question, how can you increase intake? Take some salt out. That's the first thing I look at. Decrease the salt inclusion will generally increase intake. The other thing you can do is add palatability enhancers. And so an old Florida way of doing that was a mixture of salt and cottonseed meal. So they would take trace mineral added salt, blend it with cottonseed meal, and get that proportion or that ratio that targeted the mineral intake and the cottonseed meal intake. So either decrease intake by adding salt, or increase intake by taking salt away, or add a palatability enhancer that just makes them want to consume it better. I might add one point that I didn't talk about, and it's the #1 recommendation that we always make when we're addressing how you deliver minerals to a cow herd. If you are feeding a winter supplement, always add your mineral to the winter supplement, okay? You're feeding the cows anyhow, So have your mineral blended into the winter supplement. So here at the station, we feed a liquid product supplement 3 times a week or twice a week, either Tuesdays and Fridays for some herds or Monday, Wednesday, and Friday for other herds. If we were a traditional production situation, we would blend our mineral right into that winter supplement so that we didn't have to worry about the cows deciding if they crave salt or not. We would directly feed them. That's called control feeding mineral. And you can do that over that period of time that you're feeding winter supplement. For people that are on webinar that might be purchasing winter supplements from commercial companies, a lot of times those companies fortify those supplements with minerals, and you might be feeding them anyhow and satisfying the cow requirement just from your normal management system. Okay. Dr. Bendermead.
You mentioned about sulfur in the water. How about sodium in the water?
Yeah. So the question was, I didn't mention anything about sodium in the water, and that is a big issue. So there are parts of Florida that are experiencing saltwater intrusion, and the cattle, although it might not be at a level high enough to hurt cow performance, they get so much sodium from the water that they don't crave salt at all. And so those cows will not go to the mineral feeder to eat, or they do so very unreliably. In those situations, that can be a real problem. And the only way around it, and this is highly effective, but it is something, it's a change in management, is to formulate the mineral that you want the cows to eat in a palatable supplement, grain-based supplement, and feed that supplement at least once, and probably better to feed it twice a week to the cows. We do that. We've run studies on that here at the center. We can formulate that in a simple to feed range cube, or it can be offered in a liquid feed that is provided free choice for cows, and they'll get the minerals they need. But that's right, salt intrusion can be a problem, saltwater intrusion. I have a couple questions here. Does frequency of supplementation of trace minerals, salt, daily affect trace mineral status? No, the frequency of intake is not an issue. And in fact, I tell producers often, if you're measuring mineral intake, go out and measure the amount of mineral that the cattle are eating. Provide them with the amount that you want them to eat. They can go without mineral for a couple days. That's not a problem. Where it is a problem is if you go out to feed your cows and they're lined up behind you at the mineral feeder. They're craving salt so much that they're going to, go in and eat it quickly. Then you create competition for intake. That's not good, right? You want them all to have an ability to eat it. But we've ran studies here looking at frequency of intake, and we don't see any differences if cows consume mineral once or twice a week versus those that consume the same amount over 5, 6, 7 days a week. It's the same. With this individual saying, with the last 10% of efficiency being the most difficult to achieve, how much do you believe mineral deficiency plays into the last 10% in terms of Florida cattle reproduction? That is an excellent question. You know what the person that asked this, what they mean is, if you're managing your cow herd to a 90% pregnancy rate, then you only have a 10% range of improvement. And there's multiple factors that are contributing to that, right? Just weather, just environment, right? Lightning strike takes out a couple cows, right? A flooding event, all types of things can impact that. So how much does mineral contribute to that? My guess is that it probably is minimal, a minimal contribution to that total 10%. Does it have some? Yeah, absolutely. But herds that are working more in the margins of 65, 75, 80%, I think mineral nutrition can play a big, big role. But that's only in cow herds that are meeting the other important nutritional contributions like energy and protein. And so for herds that are hitting this 10% approach or 10% room for improvement, I think it becomes very difficult because there's so many factors that can impact it. Now, I don't want people to go around saying that John says mineral nutrition is not important in well-performing herds. It is. But if you already are addressing mineral nutrition of the cow herd in an optimal manner, adding to that probably is not going to do a lot to that last 10%. And one more. What do you feel about delivering minerals via liquid feed with a lick wheel on a year-round basis? Would that reduce seasonal variability of intake? Yes, it definitely will. That's an excellent way, just like I mentioned earlier, it's a great way to deliver mineral throughout the year. And you can effectively deliver mineral through supplemental mineral fortified options in the summertime. I always tell producers to be careful and monitor intake. Even though you're doing it through a commercially available year-round supplementation method, you still have to manage intake. Watch what they're eating and calculate that over the entire cow herd. Okay. So with that, if anybody out there that didn't get their questions answered and wants to give me a call or send me an email, I'll try to respond to it quickly. Thank you for your attention.